So with these, we're just going to take logs of both sides as a general kind of idea. So if we have 2 to the x is 30, then we'll say, well, log 2x equals log of 30. That's going to be true. And notice I haven't bothered to write a base. I could have any base. It makes no difference. As long as we know we're using base 10, if we were to do this on a calculator, we're fine. From there, we bring the x down. We'll have x log 2 equals log 30. Divide both sides by log 2. Our final answer, and we'll leave it like this, is log 30 over log 2. And we don't need to go any further than that. So we'll have a look at now at one with an e in it. So if we've got an e, we want to take ln's of both sides rather than a regular logarithm of both sides, because it's kind of like an inverse. Magic will happen and we'll get rid of the e's and have a better answer. So to start off with, though, we've got that 3 in front. We better divide through by 3 to both sides before we do anything. So e to the x over 2 is equal to 7. Now we'll take ln of both sides. So ln e to the x over 2 equals ln of 7. And if we haven't understood this already, ln and e are logarithms and exponentials. They're inverse of each other. What is it I raise e by to get e to the x over 2? X over 2. And ln of an e, it just undoes the operation. So x over 2 is ln 7. Timesing both sides by 2, x equals 2 ln 7. And I guess maybe it's even better to write x is equal to ln of 49. Bring that 2 up. 7 squared is 49. Let's take a look at perhaps a more challenging question now. So we've got some points of intersection. We can certainly solve this. Well, if they're a point of intersection, then that is saying to me that they intersect when e to the x minus 3 is equal to 1 minus 3e to the minus x. So we've got to solve that. Now, it looks horrible, but there's some tricks to help us here. The problem is with that e to the minus x and how to deal with it. So what we'll do is we're going to multiply everything on both sides by e to the x. And if we were to do that, magic happens. Let's have a look. So we'll have e to the x squared minus 3e to the x on the left equals e to the x. And what happened to that last term is, well, we have e to the minus x multiplied by e to the x. And remember, we add the powers, so it's going to be e to the 0. And there's the magic. We're just left with the minus 3, and that's pretty much it. And from here, it almost looks a little bit quadratic-y, doesn't it? We can move everything to one side. Let's put it all onto the left-hand side. So we'll have e to the x squared. And if I take an e to the x from both sides, I'll have minus 4e to the x. Let's put it in a bracket so you can really see that quadratic. And there we go. Now, from here, we just treat it like a quadratic. We can factorize it, okay? So, again, just like any other quadratic, I'm looking for two numbers in this case that multiply to make 3 and add to make minus 4. So it's going to be minus 3 and minus 1. And rather than an x, though, we'll have an e to the x. So we can factorize that to make it look like this. Well, that tells us that e to the x equals 3, or e to the x is equal to 1. To find x, we take an ln of both sides. So if we did that, I hope you understand by now that the e is going to cancel out on the left. So we'd just be left with x equals ln 3. And then on the right, we'll have x is equal to ln of 1. And ln of 1 is quite nice. What is it I raise e by to get 1? I raise it to the power of 0. So x is equal to 0. So we have two possible solutions. X equals ln 3, or x is equal to 0. Okay. One more question. Let's have a look at a word question, and then we're pretty much done on our examples. We've got a function. Feel free to read it in your own time, which gives us the area affected by a plague over a certain amount of weeks. it says use technology to help us sketch the graph. So what we would do, plug this into your calculator and do a sketch. So if we plug this in, first thing to say is we're not going to have any negative x values, or in this case n values. We're talking about time, a number of weeks. So we're going to 100% be starting from 0. At n is 0, we'd have 1,000. Because 2 to the 0 is just 1. So I also know that we're going to be starting from the point of 1,000. And as we plot it, what's going to happen is it's going to go up. So that's all you need. Some nice image that looks something like this, probably a lot better than mine, will do. Hence, estimate the time taken for the affected area to reach 5,000 hectares. Well, again, what we would do here is we would draw another line at 5,000 on our calculators, something like that, and we would find the intersection point, and that is going to give us, or the x-coordinate of that intersection point is going to give us our answer. That is about 3.32. I can convert that into weeks and days. Maybe we say it is 3 weeks and 2 days. Now we can check our answer using logarithms. What they're asking us here is to solve the equation. So okay, let's solve the equation. So the equation to start with is that 5,000 is the answer. What is the n value? So that is 1,000 times 2.0, excuse me, pen problems, 2 to the power of 0.7 n. We'll divide by 1,000. 5 is equal to 2 to the 0.7 n. And from here, we'll just take logarithms of both sides. Again, it doesn't matter what our base is. So we'll just leave it like this. We can then bring the 0.7 n down. So log of 5 equals 0.7 n log 2. And then to find n, we'll just divide both sides by 0.7 log 2. So n is going to be log of 5 divided by 0.7 log 2. And we can plug it on a calculator, and we're going to get 3.32 at that point.